The salivary glands will be releasing the saliva, and the saliva will be cleaning the oral cavity. It will also moistens and dissolves the food chemicals, and I need to dissolve those food chemicals for them to bind to the taste buds, because if they fail to bind to the taste buds, I won't be able to have a taste sensation. It also aids in the formation of the bolus, and it's going to be breaking down the starch. If you remember, the first site for chemical digestion is going to be the oral cavity because of the presence of the salivary amylase and the lingual lipase, which are two digestive enzymes. One is going to be breaking down the starch, and the other one is going to be helping with the breakdown of the lipids. But mainly here, the ones that we need to focus on is going to be the salivary amylase. What else is going to be located in the structure of the saliva? It's mainly going to be formed of water. I have acidic electrolytes. I have mucin, IgA, lysozyme, and defensins, and those are actually chemicals responsible for you to defend your body against the pathogens. So lysozymes are enzymes that will be breaking down the bacterial cells to the outside. IgA are a type of immunoglobulins that we're going to be producing by the immune system, and those are meant for you to defend your body against the pathogens. If you notice on here, we have three sets of salivary glands. The first one is going to be the parotid gland. If you notice on here, the parotid gland is going to be located superficial to the masseter. It's going to be conducting the saliva through the duct on here. This is the parotid gland duct. It will be releasing its secretions to the roof of the mouth. Also, you see on here, just below the tongue, we're going to have the sublingual salivary gland, and located underneath the floor of the mouth, we're going to have another type of salivary glands. This is going to be my submandibular gland. So we see on here three salivary glands that we're going to have. We have the parotid gland, we have the sublingual gland, and we have the submandibular gland. And those are the glands that will be releasing the saliva in the oral cavity and responsible for the first steps of the chemical digestion in the digestive tract. Moving on to another organ that will be located in the oral cavity, those are going to be the teeth. And if you see on here, this child has two rows of teeth on each side. So how come? Simply because we do have primary or permanent dentations going to be formed by age 21. We've had 20 deciduous teeth that will erupt between 6 to 24 months of age. What happens to the deciduous teeth? Those roots will be resorbed and they will start to fall between 6 to 12 years of age, and they will be replaced by the permanent dentations. 32 permanent teeth, all except the third molars, will erupt by the end of adolescence. If you know here, what do we call the third molars? Third molars are what we call the wisdom teeth. So they usually erupt later on in life, unlike the rest of the permanent teeth. That's why actually we call them wisdom teeth, because they will erupt at an older age. You see on here, so what's going to be the age of this child? Alright, so moving on here to the pharynx, which is going to be the next part of the gastrointestinal tract after we get out of the oral cavity. So if we are passing through the oral cavity on here. We're passing through this tube, this muscular tube that we are traveling in, which is located just behind the oral cavity. This is my oropharynx. So oropharynx and the laryngopharynx on here, those are serving as common pathway for food, fluid, and air. They will allow the passage of food, fluid, and air. If you see on here, back to this diagram, the part of the pharynx, as we've seen on here, the part of the pharynx that was located just behind the oral cavity, this was my oropharynx, and the part of the pharynx that was located just behind the larynx, this is my laryngopharynx. And you see on here, the air, in order for it to travel down to the larynx and the trachea, it did need to travel through the oropharynx and the laryngopharynx. Also, the food traveling down from the oral cavity, it will need to travel through the oropharynx and the laryngopharynx. So if I'm following here the food, it's going to be passing here, oropharynx, then down to the laryngopharynx. It will keep going down into the esophagus. If I'm following here air travels through the nose, nasal cavity, and this part, as we're going to see later on with the respiratory systems, is going to be my part of the pharynx behind the nose, so we're going to call it the nasopharynx. Then it travels down through the part of the pharynx behind the oral cavity, oropharynx. Then the air travels in the part of the pharynx behind the larynx, which is my laryngopharynx, and then travels to the larynx, to the trachea, to the lungs later on. So you see on here, this oropharynx and the laryngopharynx did serve as a common pathway for both air, fluid, and food. If you remember, what are the 4 layers of the wall of the gastrointestinal tract? We did have the innermost layer. This was my mucosa. And then to the outside of the mucosa, we're going to have the submucosa. And to the outside of the submucosa, we did have the muscle layer. This is my muscularis externa, or my musculosa. And then remember, covering the tube from outside, we did have the serosa. Those were the 4 layers of the wall of the gastrointestinal tract. If we're looking on here to this layer, the muscularis externa. Muscularis externa is going to be, generally speaking, formed of 2 layers of muscles. We have a circular muscle layer and a longitudinal muscle layer. Circular muscle layer is going to be to the inside of the longitudinal muscle layer in most of the cases. In most of the different parts of the gastrointestinal tract, the circular muscle layer is going to be located inside. So we're going to have internal circular muscle layer. And to the outside, we're going to have the longitudinal muscle layer. One of the exceptions here for this general rules that I have the inner circular, outer longitudinal muscle layers is going to be the pharynx. The pharynx is going to be formed by inner longitudinal and outer constrictor. So I have the outer muscle layer is going to be circular and the inner muscle layer is going to be longitudinal like this. But how come I will not be disrupting the blood supply to the longitudinal muscle layer? Because simply the pharynx is unlike the rest of the gastrointestinal tract. You're going to be contracting the pharyngeal muscles for a very brief period of time. So you will not be preventing the blood supply to the longitudinal muscle layer. Another thing, that those muscles are fatigable, unlike the rest of the gastrointestinal tract. Why? Because those are formed by skeletal muscle tissues. They are skeletal muscles, not smooth muscles. For example, if I compare this muscles layer to the muscle layer of the small intestine, so small intestine is going to be formed of outer longitudinal, inner circular, same for the esophagus, but again, they are smooth muscles. They are fatigue resistant. They will be contracting for all day. But here, for the pharyngeal muscles, they are skeletal muscles. They are easily fatigable, and that's why you cannot keep swallowing all day long. We're going to have just a brief period of time where we're going to be contracting those muscles, allowing the movement to take place on here. Moving on to our next organ in the gastrointestinal tract, this is going to be the esophagus, and the esophagus is going to be the muscular tubes that will be conducting the food down from the pharynx until it reaches the stomach on here. So this tube here receiving the food down from the pharynx to be conducting this food to the stomach, this is my esophagus. If you see on here, the esophagus needs to pass through the diaphragm in order to be connected to the stomach. So the opening of the diaphragm that allows the esophagus to travel down from the chest, from the thoracic cavity, to the abdominal cavity for it to be connected to the stomach, this is called the esophageal hiatus. So what is esophageal hiatus again? This is simply the opening through which the esophagus is going to be traveling, passing through the diaphragm. It will join the diaphragm at the cardiac orifice, which is the opening here in the stomach. What are the digestive processes that will be taking place in the mouth? First digestive process is going to be, you see on here, this would be ingestion. So I cannot eat normally directly through my stomach, or through my small intestine, or through my large intestine. The part that will allow the ingestion to take place in the gastrointestinal tract is going to be the oral cavity of the mouth. Also, we're going to be performing a mechanical digestion, and this is the mastication that takes place here. The mastication is voluntary or involuntary? What do you think? Actually, it's going to be partly voluntary and partly involuntary. I have both voluntary and involuntary parts. So if you are chewing gum, would you be thinking every single second that you need to keep chewing the gum? No, you start, you decide, and then you start. This is a voluntary part, and then you keep going as a reflex. So the initiation itself is under voluntary control, but it keeps going in a reflexive manner. Another function or digestive process that takes place in the mouth is going to be the chemical digestion, and as we've mentioned, chemical digestion is going to be taking place under the effect of the salivary amylase and the lingual lipase located in the salivary secretions. Another function here of the mouth is going to be to allow the propulsion. And what kind of propulsion do I allow here in the mouth is going to be swallowing or deglutition. So how deglutition takes place? I have two phases for deglutition. I have the buccal phase and I have the pharyngeoesophageal phase. The buccal phase starts with a voluntary contraction of the tongue. So when you start to swallow, if you can swallow right now, what is the first thing that you're going to be doing? You'll find that you're compressing your tongue against your hard palate. This is a voluntary part, but as you keep going, do you have any control on the rest? Do you have any control on the pharyngeal muscles? Do you have any control on the esophagus? No. Everything is going to be taking place after that under involuntary control. And the centers here that will be responsible for this reflex taking place, they will be located in the medulla and in the lower pons. All right, those are the sites where I will have my control centers for swallow. So the food down here is going to become what we call the bolus. This is the bolus on here that you did form by mixing the saliva with the food and breaking the food into smaller particles. You're going to be swallowing, you're going to be contracting the tongue muscles. This compresses the food against the hard palate, creating a state of high pressure on here. This is going to be pushing the bolus to a site with lower pressure. So it's going to be moving the bolus backward to this part. This is my, again, oropharynx. Then the bolus will pass to the next part, which is going to be the laryngopharynx. So I'm traveling down from the oropharynx to the laryngopharynx. Why I'm traveling down into the laryngopharynx, you see on here, I need to make sure that this food will not gonna be passing down into my airways. So what's gonna happen? You're gonna be elevating the voice box up. The larynx would be moving up when you swallow, and in the same time, you're gonna kink the epiglottis to close the larynx. So the food is not going to be passing to the lower airways. But why the food will not be moving up into my nasal cavity and will come out of my nose? Because simply you see on here, you're going to also be closing the upper airways by contracting the uvula. So we're going to be doing two things on here. When we get the food inside the laryngopharynx and the oropharynx, you're going to be closing the upper airways by contracting the uvula. You're going to be closing the lower airways by elevating the larynx and kinking the epiglottis. So you don't get the food up or down into your airways. After that, the food is going to be passing from high pressure created within the oro and the laryngopharynx to the esophagus, which had a lower pressure. You're going to be contracting here the muscle that allows the entrance of the food from the pharynx to the esophagus, and this what we're going to call on here my upper esophageal sphincter. This is my upper, excuse me, this would be my upper esophageal sphincter. The food will then be passing into the esophagus, and what allows me to keep moving the food down through the esophagus is the peristalsis. And if you remember, we have two muscle layers. We have an outer longitudinal muscle layer and an inner circular muscle layer. If I want to allow peristalsis to take place, I would be contracting the longitudinal muscle layer, like this. If I want to perform a segmentation, for example, you're going to be mainly contracting those constrictor muscles that will allow you to divide the tube into smaller segments. So here, what kind of contraction will I be performing to allow the food to travel down through my esophagus is going to be a peristaltic movement. I will be allowing the food to travel down by peristalsis. If you notice on here, when you get the food through the esophagus, you need to keep the sphincter between the esophagus and the stomach closed, the gastroesophageal sphincter. Once you get the food all the way down to the lowest part of the esophagus, at this point only, you're going to be relaxing the gastroesophageal sphincter, and this allows the food bolus to travel down into the muscular sac. Here, this is going to be my stomach. Alright, so you do not open the gastroesophageal sphincter unless the food is ready to get in your stomach. Do not get air in the same time when you swallow. Alright, so let's check this question on here. The gastrointestinal tract and the digestive organs are positioned in the abdominal cavity by what? Can you remind me, please? What is going to be the name of those visceral layers of the different parts of the peritoneum that will keep the abdominal organs attached together and attached to the wall of the abdomen? Those are called my mesenteries. Exactly. Moving on to our next digestive organ that will be part of the gastrointestinal tract. This is going to be my stomach. And the stomach is going to be divided into a cardiac region. And this is the region that will be surrounding the cardiac orifice, the opening of the esophagus that will be conducting the food down to the stomach. Next is going to be this dome-shaped part of the stomach. This is my fundus. The mid portion is going to be the body of the stomach. And finally is going to be the pyloric region, the pylorus, as we're going to see. It's going to have the antrum, the pyloric canal, and the pyloric sphincter. So if you see on here, the part that surrounds the cardiac opening, this is my cardia. The dome-shaped part of the stomach, this is the fundus of the stomach. The mid portion on here, all this part, this is going to be the body of the stomach, and then we're going to have the pyloric region, which is going to have the antrum. We're going to have the pyloric canal, and we're going to have the pyloric sphincter. That would be acting as a valve, and that will be regulating the passage of the food from the stomach to the proximal part of the small intestine. So again, what are the four different parts of the stomach? We're going to have the cardia, we're going to have the fundus, we're going to have the body of the stomach, and the pyloric region, which is going to be formed by the antrum, the canal, and the sphincter. What do you think are going to be the different functions of the stomach? First function of the stomach is going to be to allow chemical digestion. In the stomach, we're going to be releasing digestive enzymes, as we're going to mention, and enzymes that would be responsible for the digestion of the proteins. This is called the pepsinogen. That will be activated into pepsin. And the pepsin, as we're going to learn, it will be breaking down the complex proteins into polypeptide chains, more simple proteins. Another function of the stomach is to allow the mechanical digestion, and this would be allowed by mixing and churning the food. And at this point, the food bolus that we've received from the oral cavity is not going to be called bolus anymore, but we're going to call it the chyme. Another function here for the stomach is to allow the propulsion. And remember, what kind of propulsion takes place in the stomach? Everywhere except for the oropharynx, you're going to be allowing propulsion by peristalsis. Alright. Back to the structure of the wall of the stomach, we can remember that, generally speaking, every single part of the gastrointestinal tract is going to be formed by how many layers? 4 layers, exactly. We have to the inside, the mucosa. Then we're gonna have just below the mucosa, we're gonna have the submucosa. Next is gonna be the muscularis externa, and finally to the outside of the wall of the stomach, we're gonna have the cerebrosa. What do you notice on here? How many cell layers do you have forming the muscularis externa? What do you think? We have 3 layers. Is this something that we've seen before? So what is the general rule of the muscularis externa? Remember the general rule of the muscularis externa that you have outer longitudinal muscle layer and inner circular muscle layer. You see on here in the stomach we're gonna have an extra muscle layer, which is my oblique layer. We have an extra layer other than the longitudinal, which is to the outside. To the inside of the longitudinal muscle, we're going to have the circular muscle layer. And one extra layer on here. This is my extra layer. This would be my oblique layer. So again, how many layers do I have on here forming the muscularis externa of my stomach? We have 3 muscle layers rather than having 2 layers in the rest of the gastrointestinal tract. What is the extra layer that you can see is going to be the oblique muscle layer. Oblique muscle layer. If you go back here to the structure of the stomach, you can see that the stomach also going to have 2 curvatures. We're going to have a large curvature. This is my greater curvature. And we're going to have a smaller curvature. This is called my lesser curvature. Lesser curvature. And you see on here, this diagram is also showing the 3 muscle layers. From outside in, you're going to have longitudinal muscle layer, then circular muscle layer, and to the inside, we're going to have the oblique muscle layers. Those are the 3 muscle layers of the muscularis externa of the wall of the stomach. You see on here also something very characteristic to the stomach is going to be the presence of those elevated ridges in the gastric mucosa. And those are the rugae of the mucosa. You see on here, I don't have this smooth surface of the gastric mucosa like I do have in the rest of the gastrointestinal tract, but I have pits on here. I have those depressions in the epithelial lining in my gastric mucosa. So I'm slightly different in terms of mucosa, in terms of muscularis externa compared to the rest of the gastrointestinal tract.